All right, so today we are discussing internet hardware. So how the internet actually communicates. The internet is a network of networks. It is a large connection of a whole bunch of networks. Now the question that arises out of this is, what is a network? And a network is a group of two or more computer systems that we have linked together. So we're linking them together so that they can communicate with one another. So if I have two computers and I want to send a smiley face from the computer on the left to the computer on the right, I can use that connection. Boom. Computer on the left sent a smiley face from the left to the right. Now, as we increase the number of computers in our network, we need a connection between every single computer here. Now, this works when we have a small number of computers, but the solution is not very scalable. It does not scale very well at all. Even with just 4 computers, I need 6 connections. And adding another computer, I need another connection for every single computer in the network. And since there are billions of devices connected to the internet, it is not feasible for every single device to have a direct connection to every other device. So what is the solution to this? Well, the solution, at least at this small scale, is to have every device connect to a central hub called a router. This is what is going to route all the signals from one computer to another. And now each computer only needs to have a single connection to that router in order to actually be connected to all of the others. So if I wanted to send a signal from bottom left to top right, say I have a smiley face again, the computer down here is going to send a signal to the router saying, hey, I want to send this message to the computer at the top right. I want to send this message to that computer. So send the message, the router gets the message, and it will direct that message over to the other computer. And now we've fully sent that message across that connection. Sure, chat actually open. There we go. So we now have transferred that all the way up to the other computer. And one router is capable of connecting a pretty good number of devices, especially modern routers are really good at connecting lots of different devices, provided that they're all close enough together. Generally, a small network like this is going to be able to encompass devices in a single room or in a single building. Your home probably has a single wireless router within it so that all of the devices in your home have Wi-Fi. Now, as we increase our scale a little bit, we have local networks all over the place. We have our local network at home, we have our local network at school, and we have our local network at, let's say, at a Starbucks. Now, how can I connect a computer from my home to a computer at school? Those are in different local networks. So what we're going to need to do is we're going to add something in the middle. We're going to add another router. We're going to route from each of the local networks through a router to connect to each other. So my home is connected to this big router, which is connected to school and Starbucks. So now those two computers have a direct connection to each other. I can find a path to get from one computer to the other. I can send a signal, I can send a smiley face from one end to the other end. But once again, as we increase our complexity, as we increase the number of networks we're trying to connect, we're going to overload our poor single router that's connected to everything. So even this is not super scalable. So let's talk about the internet. The internet itself, the whole thing, is a huge, huge network of routers. And each of these routers is not connected to every single other router. Each one is connected to a few others, but eventually you can get from one to another. They're all interconnected at some level. So our local networks can connect to the internet, to that huge sequence of routers, that network of networks. We can connect our local network to a single router, and that connection is often facilitated by a company called an Internet Service Provider, or ISP. Companies like Comcast or AT&T are Internet Service Providers. So once my local network is connected to the internet, connecting all of these networks together, we can then find a path to get from one computer on a local network to a different computer on a different local network. I can follow path, and there we go. I can find any of the computers on this network from this network if I just follow a long enough path through the internet. And for right now, we don't really need to focus on how this huge interconnected cloud of routers works. We're going to abstract that away. We're going to call it, this is the internet. I connect a network to the internet, and then it is connected to all of the other local networks. So this is what we mean when we say that the internet is a network of networks. We're connecting a whole bunch of networks together so that they are all able to talk to each other. So the basic functionality of the internet, this is the primary reason it exists, is to send information. So if I have, once again, I'm sending a smiley face from one node to another node, one computer in this connection tree to another point. So I can find a path all the way to that other computer and send that smiley face. But we're not sending a physical smiley face from one computer to another. What we're doing is we're actually transmitting some binary values that are going to translate to those characters, to the colon and the parenthesis, to make that smiley face. So how does the internet actually transmit that digital data? This is the problem that we need to figure out. This is what the internet does. It's transmitting digital information from one computer to another. So there are three primary ways that the digital information is transmitted from one computer to another. And those three ways are via electricity, via light, and via radio. So let's look at each of those different methodologies. When we send bits with electricity, the most common cable that we are going to be using is the Ethernet cable. This is the most common for sending the digital data with electricity. The Ethernet cable is full of little copper wires, and we're going to use those to send any electrical signal we have from our computer through the internet to another computer. Some pros of Ethernet is that it is cheap. It's much cheaper than the alternatives. But some cons, it does not cover enormous distances. It can only cover some medium distances and short distances. So how it actually works is when we are sending our bits, we can send a 1 by sending a high voltage across our electrical cable. And to send a 0, we will send either low voltage or no voltage at all. And that will transmit that 0 across. So we can send sequences of high or low voltage to translate to a whole bunch of 1s and 0s. If we want to send bits with light, then we're going to use fiber optic cables, which are what are used by internet service providers to actually connect everything. So fiber optic is really good at transmitting information for a very, very long distance. This is the kind of cable that is used in the oceans to get different continents connected to the internet, all connected to each other. But the con to this is that fiber optic cabling is very expensive, and that's why we don't use it around the house in our day-to-day use. We use Ethernet because it's much, much cheaper to transmit data using electricity than it is using fiber optic cabling. The principle however, is very similar on how we actually transmit data. To send a 1, we're going to set a bright light through the cable. And to send a 0, we shine a dim light, or we turn off the light and say, hey, send a 0. So we can alternate bright light, dim light to send 1s and 0s across a fiber optic cable. Our third method for sending digital data is with radio waves. And this is how a lot of us are going to be connected to the internet, is via Wi-Fi or via a cell tower. So the pros to this is that it's completely wireless. We do not need to plug anything into our computer or our phone in order to be connected to the internet. We're using wireless digital data transfer. However, wireless data transfer is much, much shorter in range than either of the two alternatives. So Ethernet you can get to go for quite a while, but routers, wireless routers, are usually going to be restricted to about one home, or not huge in size. But the principle on how we're actually going to transmit 1s and 0s, very similar once again. To send a 1 via radio waves, we're going to send a high frequency wave. To send a 0, we send a low frequency wave. We can alternate to actually send signals. All right, so does that all make sense so far? Any questions on any of that? Cool, all right. So let's look at how we might actually send some bits from one computer to another. So if I'm sending the signal 1010, we're going to send a high signal. We're going to send a low signal, high signal, low signal. And there we go. We have sent that message from one computer to the other, and we have received the exact same message that we were trying to send. Now, are there any potential cases where this wouldn't work? What problems might arise here? And have a guess. What if I have numbers that are repeated? So if I have the sequence 10001, I can send that 1 just fine. I can send that 0 just fine. But then when I try to send that next 0 and that next 0, the computer on the right has no way to differentiate between those different 0 signals. So when we see that 1, we're going to say, oh, we got a 1. It changed. Now, 10001 and 101 are not the same number. So we have a disconnect in our signal transmission. So we need to make some change that's going to allow us to keep track of when there are repeated numbers. So to solve this issue, we're going to introduce a clock to the system. So we're going to have the computers agree on how often they want to send and receive bits. So we're going to send a 1, and then in the next second, we're going to send a 0. And then in the next second, the signal didn't change, but a second passed, so we're going to take a 0. Then another second passed, we're going to see another 0. And then another second passed, and we send a 1. So now our signals match. We've sent 1 bit every second. So now our messages actually match, because we have that, even though the signal didn't change, we know a certain amount of time passed. So we're going to say, oh, the signal is going to be the same because it's the same number. It's going to have the same value repeated. Now, in this example, where we're transferring 1 bit every second, this is mind-numbingly slow. This is so slow. Fortunately, computers are much faster than that. The amount of data that we can transfer by a single system is called the bandwidth of that system. So how fast a system is able to send and receive data, that's its bandwidth. And this is measured by bit rate, which is the number of bits that we can send or receive in a single second. So my bit rate in this example was 1 bit per second, very slow. So my 1 bit per second gives me an excruciatingly low bandwidth. If I increase my bit rate to 5 megabits per second, then my bandwidth is going to be high. That's a much better bandwidth. I'm transmitting 5,000 bits every second, which is going to be much, much faster at transmitting data. Now, the last thing to take into account when we are talking about digitally transferring data is the idea of latency, which is the amount of time that it takes for data to get from the sender to the receiver. So how much time is spent on the actual transmission. If we have a system with low latency, that means we have a fast connection. Now, fiber optic is the lowest latency possible we can get. It transmits data at the speed that light is moving through glass, which is very, very fast. So the latency we introduce is about 5 microseconds every kilometer. Ethernet cables have a much higher latency with about 300 microseconds introduced every kilometer we travel, although we're usually not going to have Ethernet cables that are a kilometer long. Usually they're going to be much, much shorter than that. Usually going to be within the same room or within the same home. So the latency is not going to be hugely noticeable through Ethernet. So to recap what we've talked about, we have the internet, which is just a network that connects networks. We're connecting a whole bunch of local networks all together to create this huge web we call the internet. A network is just a group of 2 or more connected computers, and we're typically going to use a router to connect those computers. There are those 3 ways to send our digital information. We have electricity with Ethernet cables. We can use light with fiber optic cables, or we can send information using radio waves over Wi-Fi or with a cell tower. And no matter what type of connection we're using, electricity, light, or radio, all we're doing is we're sending bits. We're sending 1s and 0s. So we're not sending anything more, but we're not sending anything less than that. All right, any questions on any of that? All make sense? Cool.